All right. Well, good morning, everyone. Welcome to this week. Probably get into geography, which is a topic that a lot of people really enjoy, the mapping and pulling together what has classically been a large part of the farm planning process. Um, Days gone by, the farm planning process very much focused on everything geographic and all of those development layers. So pulling the aerial photo together, and back in the day it was with clear plastic overlays, displaying a feature plan. We display all of the existing mark on there with a marker, all of the existing features of a property, and any land classes and different soil types, etc. And then you put another layer over the top, and topography, and then you put over another layer over the top with all of the things that you might want to do, the development potential there of the site. These days, we're doing it digitally. You can still do it manually if you wish, but it's nice to go back to that sometimes. And in this program, we do it all digitally. So today we're going to talk to you about, and it's a pretty jam-packed session, this one, probably one of the most jam-packed that we have, in that we're going to look at how to use Google Earth through the lens of our program here, with the expectation of all of the outcomes that we have, which will be that you'll have some core competency in being able to use Google Earth. And secondly, then how do we look at embracing some of the core elements of the Keyline plan, particularly when it comes to the geographic part, or the Keyline geography, I should say, and what's that primarily about, and how do we apply that to our work here in farm plan development. So without further ado, and it looks like I've got a few on here, which is great. So thanks for joining us. I'm going to get into the program. Now, the core reference for this particular piece is the Agrarian's Handbook, and it's the geography chapter. Just happened to, because we're just about to go into pitching mode with high net worths and anybody else who wants to help us make that volume fatter. That's the three chapters of the Agrarian's Handbook, and that's about the size of it. But I think it's probably going to end up a bit more brick-like if that's only 3 chapters so far. So this is where you need to go to chapter 2 if you have one of these, the geography chapter, and that's the primary reference for the next couple of weeks. Where we're doing this week, we'll be doing the farm mapping and Keyline plan, and the next week we're doing site analysis. Although site analysis definitely, these 2 weeks, 4 and 5, very much blend in together. People are trying to get all their maps together. They're trying to get their heads around Keyline geography, and trying to, in a lot of ways, make decisions about what they should and shouldn't do as far as going down various rabbit holes, because believe me, there are quite a few here. So that's what the next couple of weeks are going to be about, as well as trying to understand what your landscape's telling you in terms of its state. So that's the primary reference. And then the week after that, we'll be doing water. As I'll show you in a moment, we've just made this available to you as planner subscribers, so you can now and do what I did here, if you like, which is just go down to your local print shop and get one of take the file that we've made for you. So we've replaced, just so you know, if you go into the November, February Rex thing there, you'll notice that I've taken out the 2 old files, and you've got one Agrarian's Handbook chapters 1 to 3, version 10. Don't share it, of course. We want to make something out of it, so we can keep paying for its development and help keep funding the work that we do at Agrarians. But by all means, download that. It's 181 megabytes, so it's not a small file. Take it into your local print shop and print it in an A4, which is a full or a letter size print, or as we've done, printed into this nice little A5 version, which is what it's designed to be in terms of, so that's 2 letter sizes that is there. So, and get it bound, and it's a really, you'll start to get the sense of how we have set this whole book up. And, you know, I can't wait for the day when this is completed and when we're doing this program, that I'll be able to direct you to page X, and you'll just flick there physically and you'll go, ah, right, okay, that's where we are. So very much looking forward to that moment. And but, you know, we're up for where we're up to this year. You'll definitely be able to see yourselves covered in the Regrarian's Handbook. Right, now, in terms of today, what we're going to try and look at is Google Earth Pro and these headings. So I want you to understand the menus and functions, how to set up the preferences and settings. What is it about geographic projection? What does that actually mean? So we'll look at that. Setting up your folders, the save options, because that's important. How you share with us what you've done in terms of building your farm plan. How do you import data? How do you import images and as overlays? How might you deal with any GPS data that you've got? And then look at any sharing options that are available, again, with how you share things with us and so on. And then the Keyline plan, we're just going to focus on the Keyline geographic elements, and I'll talk a bit to that, as you can probably see on the side screen there. Last night, I shared with you, or shared with the workplace, a link to this download. So if you haven't already got that, I'd advise you, please, in today or tomorrow, whenever you get a chance, go to the link that I posted in this week's. So let's go to there, week 4. Here we are. To week 4's page, and you'll see here that, just make that bigger, you'll see here that I've uploaded I've given you 2 links. One is to the Google Earth Pro download, so get a copy of that, and that'll just take you through the steps. You can do that on either Windows or Mac. I don't know if there's a Linux version, but have a look there. And then the other thing that we've done is we've created a folder template. Setting up Google, one of the biggest deficiencies of Google Earth as an app is its folder structure, as compared with many other, and its layer structure. So we've done a bit of work in the background to sort of make negotiating that a lot easier for you. And as we'll demonstrate soon, we've set all of the folders up according to the Regrarian's platform. So it makes it really easy for you to find where you are, and that'll all become self-evident as you start, well, perhaps when I demonstrate it, but particularly when you start developing your farm plans. So we've done the hard work for you there, and that'll make your life a lot easier, and it'll mean that you can just navigate yourself around and get to where you want a lot easier. Because if you don't have that, it'll probably start to look a bit like my desk right now. It needs filing. All right. So just come back to here, and I'll just I'll go straight to Google Earth. So let's have a look at what Google Earth Pro looks like. Let's get rid of that for a minute. So James, you can see I'm going to use you as an example this morning. You'll be pleased to know. All right. So first things are the menus. So what we've got up in the top left-hand corner is you've got, and again, please, this is a Mac version. There's subtle differences between the Mac version and the Windows version. And I'll speak to some of that in a moment. But what we see here in the Mac version is these 7 menus here, apart from the Google Earth Pro, and they, as with all apps, help you to direct you to do all the different things. Let's just have a look at the different menus and functions within that are sort of most commonly used. So opening is when you open a Google Earth, when you open something in Google Earth, there's a range of file types which it will open. It is fundamentally what's called a GIS, or a Geographic Information System software. It's quite universal. People all around the world use it because it's free and because it's simple. And the other reason why they use it is because it'll open a relatively wide range of file types. And a lot of different apps out there, GIS apps, now have a lot of compatibility with Google Earth, because they realize that there's a user base out there that all use Google Earth, and they might use their own very high level apps to do very high level, high resolution work that Google Earth is not capable of doing. But then it's got to speak often to Google Earth in order to be able to communicate to a client who doesn't use that high resolution app that might be $2,000 to $10,000 and requires a higher level of training, perhaps, to even understand how to open. So it is a good app from that perspective, in that it's sort of like a bridging app, which is really helpful. And one of the reasons why we chose to use it as opposed to others that are out there for the purpose of this program. So it will open. So if you click on open and you're in a particular folder and it comes up as being black as opposed to shaded, then that means it can be opened. Now, there's two main file types that can be opened in Google Earth. One is called a KML, and the other is a KMZ, or a KMZ for those of you in the United States. Those are the two outputs. So a KML is the main file type. A KMZ is a zipped KML. So when you've got a big file that you've created in Google Earth, often it's better to save it as a KMZ, because then it reduces the file type size. But when you open it, it'll expand again. Anyway, we'll get through that. So that's one part, the normal open thing. We'll have a look at that more in a moment. In here, there's not much to show there as far as the edit functions, and I'll move along from there. In the view, this is where you can set up to show different things in the window itself. And so I'll just move that out of the way. A minute. If you look over in the top right-hand corner, you can see that there's a navigation. There's a couple of navigation tools there. So there's this, quite obviously, the zoom. So you can grab it, or you can just click on it. You can also, with the modern mouse, you can just scroll with your mouse as well. This one here is sometimes you need to move around, and you use this when you've got an active bit of editing going on, and you can't scroll because your mouse is being used for other things. So you come over here and scroll about with the hand tool, and it'll take you in a whole 360-degree movement. This is the north arrow up here. So this one, if you find yourself for some reason off track, then you can also just press, and north is not up as it always should be on a map, or there's sometimes you want to tilt the map in a particular direction because your property it has an east-west axis, a north-south axis as a rectangle. And to fit it on the screen as well as you can, it's actually better to swing it around so that east or west is up on the map, and so you'll swing it around. But then when you want to go back and get your head around where north is, just press the N key on your keyboard and it'll take you back up. Similarly, if you press these ones here, this is when you'll actually go into more of an oblique view. And if you've got that, so what you can do there is go quite oblique, or you can tilt yourself back. But an easy way to get yourself straight back up is press the U key, and you'll go straight back to the full plan view. So they're pretty simple things there. Other tools, this is where we, let's have a look, is there anything else there? Oh, historical imagery is a useful one. This is where you can, if you're on a particular property, you can go back. I'll just go to one here. Just bear with me. Let's have a look at Keyline properties. There we go. Let's have a look at the tragedy that is Yobani these days. So this is where, this is one of P.A. Yeoman's quite famous properties, Yobani, which is being carved up and turned into a housing estate. So you can go back in time and see, so you can scroll back. If there's the available imagery of your area, you can go back in time and check out what it actually looks like, or what it's changed into being over time. So you can just click along here, and it'll give you a sequence of different imagery that's been captured over time. In which case you can then, and you'll see here on this line that there's quite a lot of change, like not many photos for a while, and then all of a sudden come to this era, particularly post about 2013, 14, there's a lot of areas, particularly urban and hinterland areas. There's a lot more coverage in the last 5 or 6 years. So you'll get a lot more different photos over a period. And you see, sometimes this will happen with one of those photos. You'll get that. Now, so for some of you, you might open up your Google Earth file and go, oh, God, it's all covered in cloud. Well, and you just say, oh, I can't use this, without realizing that there's this tool up there, and this might be your latest photo. So you might find, well, gee, I'll go back in time and there's a better photo which doesn't have the clouds. And it may even be a better resolution. It just depends on who Google got the data from, because that changes too. Different satellites and different satellite companies and whatnot provide their data to Google. And this is where you start to see the unraveling of Yobani as it's being developed and torn apart. Anyway, so that's what we use that for. Okay, James Lacey saying, your screen seems to have frozen. Video working okay, just Google Earth window. Has anybody else got that issue? Just so that I can, hi, our screen. Same here, okay. Okay. All right, so that might be something at my end, is it? I might just stop the share for a minute and reshare and see if that helps. Okay, let's go again. All right, just let me know if that's still the case, where it's still frozen and you can't see my mouse moving, etc. Just pop it in the chat if you can, because it's a bit easier to see. Okay, if someone can, so I'm moving the screen now. If anyone can reveal that that's still occurring, that'd be awesome. Drop down some menus. Yep, back. Good. All right, fantastic. All right, well, we'll continue on with the show. Thanks for letting us know, people. So that's a useful thing. Otherwise, have a play, have a look at the sun and the atmosphere and the water surface. That's kind of academic from my perspective, some of that stuff, but have a play with that when you've got some time. Now, the other thing you might want to do is sometimes you might want to take a screenshot of what you've got on the screen here. You can take things away, so that takes away the navigation. Once you've done that and you want to get it back, well, then of course you're going to have to do so. So I've got that there, automatic, and so on. Sometimes I don't want this historical imagery, so I'll get rid of that as well. And that'll just take me back to the latest image that's available in this case generally. All right, now other things are the different tools. So you might want to have some sort of ruler. And the ruler is quite useful for measuring distances between things. So you might want to say, well, what's the distance between this water conservation channel and this irrigation channel? So you can just simply click on there and then drag that out, and that'll tell you what that is, and also what heading it is. So what degrees off zero that would be. Thank you, my love. You can also, and once you've done that, you can clear that. You can also do a path. So say we want to measure how long this channel is. Well, I can click that. So it's a multi-node path. Those little intersections are called nodes in this language. And what you can do is just go along and click that. Now, all the way the meterage is, or the length is being determined. And you can go from there to there and go, okay, well, that's 295 meters or feet or whatever, or smoots if you want. So we can measure things. We can start using smoots in our language. You can save that, and then that'll become a line, and that's a whole nother story in a moment. You can also show the elevation profile of that to show that over that length, it has a change in gradient, which is, well, we'll talk a bit more about that in a moment, but that's one of the useful tools that there is in Google Earth, and what average slope it's got and what the slope is at any given part of that line. So you can do that, and so on. So we'll just clear that. Another thing you can do is, say I want to measure the area of this dam here to help me calculate its volume. Well, then you can click along that. Oops. And I won't do the whole thing, but let's say I just want to know what the area is here. Well, I can click along there, move those, put the nodes in, and then from that, it'll tell you in hectares, whatever you want, acres, square feet, whatever suits. It'll tell you what the perimeter measurement is of that polygon, but also the area of that polygon. And from that, you can do all sorts of area statements. You can clear that or save it if you're going to use it for some other purpose. You can also do a circle. Circles, you start in the middle and then you bring out your radius. And then that, and this is the way that we actually draw circles in Google Earth as well. So it doesn't have the full, like I said before, it doesn't have the full array of tools that a lot of other GIS have, where you can just draw a circle simply and you can drag it. That'd be one thing I'd love for Google Earth to be able to do, and that's to be able to grab a line and actually drag it without, you can't do that. That's a limitation. And same with a circle or a polygon. You can't grab it and drag it once it's created. You have to recreate it, which is it's not a massive shortcoming, but it's something that would be great for them to overcome. So that gives you that. I haven't used the 3D path or 3D polygon to play with that, but that's something you might want to do. All right. Otherwise, some of that's folder management and whatnot, which I'll talk about later, and your zoom and a few other bits and bobs there. So we'll come back to some of them. Now, the other piece that I wanted to get to was around preferences and settings, and setting the thing up. So this is important. Points in the Q&A. Let's get rid of them so that I've got that all good. Done. Right, great. So if you're on a Windows computer, I think what you'll have here is properties, not preferences. So same dog, different legs. So what we'll do here is just click on there, and once you click properties or preferences, the window that you come to now is largely the same, no matter what operating system you're using. So this is where we need to understand a little bit about some of that projection stuff and whatnot, which I'll get to in the next part of this session. But what you want to do is look at, in particular, if you need icons of particular size, well then, depending on your eyesight, we'll then check that out. Check out which do you want to show down in the bottom corner here. You'll see in the in the screen here. Let's move this. you'll see that I'm set to degrees, minutes, seconds, and points and decimal seconds. And then you've got elevation down here. The imagery date is fit there, and then the eye altitude. So that's how far above we are of this landscape by eye, and the elevation is the elevation of the cursor at any given place on the map. And I'll talk about that in a minute too. So you'll check that. Some of you will want to use what's called universal transverse Mercator, which is another projection system, or some other one. You might want to use decimal degrees instead of degrees, minutes, and seconds, and so on. So there's different ways that we'll play that, and we'll talk to that soon as well. But usually, you know, we're metric, so it's only really the US and what's that place called, the UK, who do imperial, because for whatever reason, we use metric throughout. So, so if you don't use metric, well, then you're just going to have to convert at some stage, or set it up in this way, and yeah, just realize that that's our default at Regrarians. All right, so set whatever you want, press apply, and that will get you to where you want to be. Right now, the other parts in here is setting the cache. You can just leave that as it is, although if you're into cache management because you've got limited space on your computer, well, then that's something you might want to look at. Google Earth does cache what's on the screen. So if you're working on a laptop, for example, and let's say that you are going out into the field where you don't have internet access, Google Earth is a cloud-based app. To an extent, it's got parts which it caches and saves on your computer, but then other parts, like if I want to go and look for somewhere and I'm out in the field and I'm not connected to the internet, it'll navigate me to that point geographically, but the imagery will have low resolution or no resolution. So what you do if you're going out into the field and you want to take your laptop out and you want to look at things, or let's say you're giving a presentation or something where there's no internet, then make sure that you open to where you want to study while you are connected to the internet, and Google Earth will cache that. It will store that on that computer, and so that when you go out there, you'll be able to open it up and you'll be able to see at the full resolution. So that's important. You may want to up that in some cases, depending on what the scale of the site that you're working on. But I haven't found it to be too much of a problem at 2,000 megabytes. But have a play with that if you're up for it. This is a useful one if you're doing particular styles of fly-throughs and all of that sort of stuff. I'm not going to deal with that today. I'm just going to deal primarily with how to do the core functions of file mapping with this app. But that's stuff to play with. Like with any app, there's always a lot of functionality which you may not ever use, but is there to have a look at if you wish down the track. Now, navigation is one that is useful. Now, you might have known, like I'll just click on the Oaks here. So we'll just get out of this for a moment. So let's, or Taranaki Farm, a few of you are familiar with that property. So you'll notice that that's navigating in a way where it comes directly to it and it stays in plan view. Now, the reason why it stands in plan view is because I've set this up so that in the navigation, it doesn't automatically tilt while zooming. So let's just select that and I'll apply it. And let's just see what I mean by that. So we'll go to New Caledonia. Let's go there. Another property that Yeoman's worked on. So what you'll notice now, oh, actually that didn't work. Okay. What that should have done is, let's try that again. Automatically zoom. I think that's apply. Okay, let's try that again. We'll go to null avail. That'll do. Okay, it's making a liar of me here, so won't worry about that. that setting is sometimes those of you who've used Google Earth would know that sometimes you'll zoom in and it'll tilt as it does that. You can press the U key and it'll just go back up to plan view, but I find it annoying, so I just turn that off. I have as a default setting that do not automatically tilt while zooming, because it's a pain when you're zooming in and out that the map starts to tilt to oblique. It's a pain. All right, so there's that. Let's have a look at any other preferences there. Then general preferences. Now this is important. Depending on, like, if you're using a Mac, I find OS X Mail a pain in the butt. So I just use my Gmail account in my case. You can set to whatever language you use. So for some of you, you'll be using different languages. So set up there. It may already default to that because it's recognized that you speak a particular language anyway. Yeah, there's not much else there. Tooltips are useful for a lot of people, especially while you're still learning how to use the app. I don't really need that, so I'll turn that off for me. Building highlights, I don't know what that is, so I'm going to turn it off. Yeah, I think that's about it in there. So that's all I've got to give you there. We can come back to that later if anyone's got any queries. If anyone's got any queries now, just put your hand up and we'll go through it. All right, now let's have a look at geographic projection. So for that, I'm just going to take you back to, I'm going to take you to here, to the Librarian's Handbook. And I'm just going to make that a bit bigger. Oh, yeah, here we go. So in the world, so this is on page 86, 87 of the Librarian's Handbook, there's a discussion around what's called geographic projection. So all around the world, there's, well, I'll go back. Navigation of the world has been something that's been really well developed over the last 500 years, and particularly once once the world was discovered to be round, to be spherical, that changed everything as far as how we understood navigation to be. And then there occurred these different grid systems, which started off with the, in particular with the Mercator projection, which basically tries to, because when we look at when we do mapping, we're typically doing it on a plane view when we're actually dealing with a sphere, and so we have to have systems of projecting that difference. So that we have accuracy, because obviously we're dealing on a plane with something that's actually spherical, and so there's mathematical issues that come up with that naturally, particularly as you get to larger sites. How cartographers have dealt with that is by developing a range of different projection systems. And so we project the world in a whole range of different ways. And some of those different ways are revealed in these different map projections that we've got here. Now, with the West having developed most of these systems, they've been quite, and there's some contention around this, it's been a very interesting outcome as to how the size of Western countries has been projected to be larger than the size of non-Western countries. And for example, you'll see on this equal projection, for example, that Africa is substantially larger than North America, for example. Or than Europe. Europe is tiny, whereas when you look at the normal Mercator projection, places like Africa are smaller, North America is larger, and Europe is disproportionately larger than it actually is. And so forth with that. A little Denmark, who owns Greenland, their territory looks much bigger than it actually is in this particular projection. So that's a distortion as a result of the particular projection. So there's some of that in there, which is interesting. So anyway, I won't go down that rabbit hole because there's lots to go down here. The principal thing to understand is that there are different projection systems, and you'll come up with against this sometimes, particularly in places like the United States, where you're getting, if you go and get data from your state, because the states are often the repositories of a lot of data, you'll see that when you actually go and look at the projection that they use, it might be what's called a state-based coordinate system. They're not using necessarily a universal coordinate system, they're using a state one. And then when you go and use that, and you try and put it into something like Google Earth, with other data which has come from another projection system, they may not mesh up. They may be quite far apart, right? Now, what's the basis to that? Well, the basis to that ultimately is the military purpose, the military uses of maps as they have been. Most maps that we use have been developed for military purposes. And a lot of the innovations that have occurred in cartography, mapping, navigation over the journey have been by the military. And so just imagine this. I'm from Spain, and at this stage I'm fighting against the English, and I come across a map. I hear, I get some intelligence that the English are going to attack at this coordinate, right? This longitude and latitude, right? And so I'm going to go there and I'm going to ambush them at this moment, right? Well, the ambition, so what the Spanish haven't realized is that the coordinate, the longitude and latitude that the English are using is based on a different projection system. And so they might be a mile out as a result. So they get there and go, well, where are the English? They're not here because they're using a different projection system. So their intelligence was wrong. So what we see with these different systems is that has actually come down and filtered down into the different civilian uses of maps and the different civilian projection systems, and that can be a cause of confusion. That's why we primarily use either, just straight longitude, latitude, because there's a universal convention for its use within the what's called the World Geodetic System, or WGS. Or we use something that's metric, which is called the UTM, or Universal Transverse Mercator. So when you come back to your Google Earth platform, that's why it's important to understand that little. You don't need to understand it completely, but just go back to here and select the right projection that might be working for you in your locale. So I find myself switching between both. I see the world through the lens of latitude, and that's the way a lot of us, because latitude is a ready, we measure sun angle through latitude largely, right? And so I will often have this on here because I can immediately look down there and I can see where people are from a latitudinal perspective. Longitude doesn't matter so much because that's just where you are on the up and down. It's the horizontal plane. That's the horizontal lines on a map grid which relate to latitude. And if I switch over, for example, to Universal Transverse Mercator, it doesn't show me that. It's a metric system that works on a completely different basis, and that's all explained in the Regrarian's Handbook. So just to help people negotiate that. You'll actually see, if you go down into the appendix, I think, if I remember correctly. Yeah, so there's the UTM map of longitude, latitude, if you like. But if you put up, if it came up K, I just wouldn't recognise where K was. But if I see that it's 37 degrees of latitude, then I go, right. So it's really the grid language that you become familiar with, and a lot of us are familiar with latitude and so on. So Yeah, so just so you understand that it's not, like I said, you don't have to get into it into any depth, but you need to understand that it exists, so so that you can work with it. Basically, if you want to go in deeper, well then by all means do. All right, other parts. So geographic projection. All right, let's get back to Google Earth and setting up folders. Right. Now, you'll notice that in, where are we? I've invited you to open up this folder template. So this will take you actually to an earlier post, which will allow you to then download, or invite you to download this particular template, right? So I'd invite you to download that to whichever folder on your computer works for you. Once you've done that, then go to Google Earth and click Open, and take yourself to where that folder is, that file is, and open it. And then what will happen is it will open it up on the side here. Now, obviously, I use Google Earth a lot. I've got it set up in a particular way so that it's really well organized, because, you know, when you're trying to manage literally thousands of people at times, you need to have some organization. Even that said, if you're just doing your own place, you need to have it organized. Otherwise, it's going to be called what we call in Australia a dog's breakfast very, very quickly. So this is the template here. You'll see here that it'll open up like this. So it'll say Agrarians Platform GE template.kml. Now, when you click underneath that, you'll see it says the same thing. Now, it's broken up into the different Agrarians Platform layers. Now, what we've done there is we've set it up so that so if you've got climate-related information that might want to go in there, for example, some statutory layers or whatever, that's largely what would go in the climate layer, well, then that's where you'll put them. From a geographic perspective, we've got, and this is, we've added in already folders, but we've also added in some information. So you want to go and look at all of the Keyline properties of the world that we know of. Well, then we've added in all of those. So you can just, so if you want to go and have a look at Carisbrook Station, you know, oh gee, I've heard about Charlie Flotta, wouldn't mind going and looking at his 250-acre dam and 1,200-acre irrigation system. Well, then you can go straight there without having to muck around. So there's a number of theirs on it. Looks like I need to update that. So there's those. So you can do that. There's topo maps. So topo maps. Oh, that's. So what we've done here is saying, all right, well, if you have a topographic map, then that's where you might want to put that. All right, and I'll show you what that means in a minute. If you have site features that you've developed, well, that's where you want to put those site features. So, so you're starting to build up information in layers, which you can turn on and off with a click, right? Then we look at water. So we've set this up so that and this again is according to how most people are using it. And, you know, we've done a number of programs over the years, and so we get to see how people are, the kind of layers that people are working on. So this is how we've set this up, is fundamentally built off the back of feedback from people like yourselves. So when you come to the water layer, what do you need to do? Well, what do you need to map, right? So I don't know that he's on here this morning. But, you know, like any of you here, for example, might want to start off your water layer by marking on the map all of the pipes that you have. So that's what you'll do there. So you'll go into pipes and you'll go, all right, well, I know that there is a pipe that is, and I'll call it pipe 1. All right, for example, I'm going to change its color so it's a blue color. And I'm going to make it a particular thickness. We'll make it 2 pixels thick. So we've done that, and that pipe goes from here to here, right? Right, pipe 1's marked. So pipe 1 now goes under, or goes straight into that. Now I want to do another pipe, because there's another pipe which goes from here to here, right? So that's pipe 2. right? And so on. So they all get put in straight away into that one. Now, if I don't want to look at pipe, so instead of going in and clicking off, because you might have 100 pipes, instead of going in and they all just get anarchically placed in your table, in your folder structure, which it just becomes a real pain in the ass very, very quickly. You just have to go turn them on and turn them off at one point, not every single one. So if I want to turn off these individually, I've got to click on them individually. But if I want to turn them all off at once, then I'll just turn them all off at once. Or if I want to turn off the water layer, I can just turn off the entire water layer all at once by having this architecture, by having this set up in this particular way. So I'll just delete those. We don't need them. So just right click and then delete. Then you've got your proposed. So this is going back to the old farm planning days where you had an aerial photo on a printed out, might be quite large, the desktop size. You put a plastic sheet over the top of that, and you put all of your existing features, and that's where we go. And this is what you'll do a lot of over the next week or two, because we haven't got to building any layers yet, where we're actually doing the proposed stuff. All we're going to do for the next couple of weeks is just mark what we have on the farm right now, not what we're looking to do, just what we have, the existing features. So we'll mark any existing dams. So you'll go in there, make sure you highlight that, and then you will add a path or a polygon, which are the main tools that we'll use for drawing. So path is a line, polygon is a solid object, right? So you'll go in there and say I want to build we'll say I've got this dam here. What I'll do is I might go to another property. This one's not the best to use. Just bear with me. Geography. Let's go to Tubrac. It's always a good one. So you might say, oh, we want to mark this existing dam here. So I'll just scroll into here. So this is a drone image that we've overlaid here. So now with that, I'll go back to where I was, which is down the page here. So I've got existing dams. So I'll make sure I'm highlighted. If you don't highlight, then the file, well, I'll show you what will happen if you don't highlight. So I'll just click on there, for example. Now I go and highlight that. I go to do a polygon of that particular dam. I've got to change that up. So I'll select it so it's blue and it's filled and outlined. So blue and filled and outlined, the same color. Okay. What's going on here? Why that is probably not the best example. Hang on, I'll go somewhere else because I think there's an issue with Jason's. Let's go to a neighboring property here. Here'll do. We'll see. All right, so I'm going to add a polygon and I'm going to draw on top of that. So you'll see that's all good. You've drawn it all fine, no problem there. And I go OK, and it's down here at the bottom, right? Now, this means if you do that, now I've got to grab that and drag it up to there, right? As opposed to what I could have done was just make sure I highlighted the folder that I want to be that I want this bit of data to be a part of, and we'll go to this dam here. And now, when I click on it and away we go, you'll see that that's now going to find itself underneath there straight away. So you know dragging. Because if you've got a lot of data, then it can be and Google Earth is not the best for the dragging stuff. So you might have to drag through a lot of files to get it to where you want it to go. You can also copy and paste. So that's another way. So if you've got it out there, you can copy and then go to where you want to go and then paste. And then that'll paste that in there as well. That's another option for you, okay? I'll get rid of them. So right click and delete, right. So you can just go along. Now, if I want to build a dam, ultimately, well, then I can basically repeat the same process using lines or polygons on here as well. You've got other infrastructure. So let's say you've got wells or pumps or whatever. This is where you might use the icon tool or the place mark tool. You'll click up here and you'll see that there's a whole range of different icons that you can use. You can also add custom icons, which I've found myself using from time to time. I think I've got some of those in my core, in geography, in GIS, and in Google Earth. Test hole symbol. So I grabbed this off the internet and I've got that. And so now I can import this test hole symbol because I want to use that as a symbol in here. So you can do that because let's say I want to, as I'm doing for a client at the moment, I'm saying, oh, we need to do test holes before we build this particular dam. So I'm going to use that symbol because it's more in keeping with mapping conventions, right? So that's something you might do. But that might be also well number 2, right? And then you might put information about that well as well. Let's say it's 100 meters deep and that it has a flow rate of 3 liters per second, right? So that information is now there. You might even add an image onto that of the actual well so that that's all stored in there. In which case, when you go, if you add an image on there, we'll just find an image, for example. Okay, let's go to here just so that we can follow this through. Water. I'll just pick anything here. So I'll pop that in there. Now, what you'll see has happened there is when I go and click on that now, I get a picture of what that looks like because I've attached that image to that particular point. This is some of the value. This is something a lot of GISs don't do, and it's really good from the perspective of Google Earth. This is one of the really key values it has. All right, I better get motoring looking up at that time. All right, delete. Yep. So that takes you through. Now, other parts that I've developed, just to quickly brush. Access layer is the same, so roads existing, proposed, utilities existing, proposed. Same with forestry, same with buildings, same with fencing. So those main, as we call them, development layers. You'll see in fencing we've got things are broken up into whether they're perimeter or into the 5 fencing styles that we have in our platform. Then we've got soils. Now, this is an interesting one. There's data that's available by different authorities and so on, institutions that have provided us the ability to, that we can import in. And so, for example, I won't use the Australian one, but the NRCS, if we just go to somewhere in the United States, let's go to Megan's in Wallensburg in New York. So if you're in the United States, there's an amazing service called the NRCS, and there's this really great service, which is her property here in the corner, which allows you to, at the click of a button, find out a whole range of different metadata about that particular property. So you'll see what this is doing is it's linking in to an internet database, which is off your computer, right? And this is all of the soil data. So these are all of the different soil types that are across Megan's property, which is this corner place here. Now, if I click on that, just anywhere on the map, this shows me what the soils are for that particular area. And if I go and look at the additional information by clicking this additional link, what it'll do is it'll take me out of Google Earth and into here. And I can go and look at all of this information about the site and its land capability class and all sorts of stuff about that particular soil. Like down the bottom here, and we use this a lot for developing, designing and planning Megan's place, because it is pretty good data. You know, what organic matter levels, percentage clay at different depths. So when we were looking at building dams, which we now have at Megan's, this gave us an indication of what percentage of clay there was at particular depths, and what level of infiltration rates. And if you don't understand what these things mean, well, then it provides you additionally, this is really super useful. I'd love this for the whole world. I don't know why that doesn't work, but it provides you with a whole lot of information about your site, even what species should exist there, and all of the different limitations there are for a range of different land uses. It's incredible. So go back to the old Aussie one, the soil landscape grid. Well, that's of a much lower resolution, and is okay. It gives you some parameters, but it's not a shade on what they've done for the US. It's a great piece of public work. So that's what we have there. Economy, there's going to be limited uses for the economy layer in Google Earth, but we've got it there, and some people find ways of using that. And then again, with energy systems, it's mostly going to be about energy installations from the perspective of generation and storage that you put there, and so on. So that's how we've set things up. So what I want you to do after you've opened up Google, got Google Earth onto your computer, go and open up that template, and then that sets you up, right? You don't have to go and, it's kind of it's a template that allows you to just get to work. You don't have to go and muddle your way through everything as you would probably otherwise, right? Well, as we've seen others, it's, you know, like I said, everything that we do is in response to feedback, and we've seen that because we didn't provide a template, that people just had these. I just couldn't stand looking at it. It was my OCD indicator went off the register at that point early on, so I had to deal with that. So it's all selfish, quite of course. Anyway, so that's what we've done there. Now, so setting up the folders we've largely done. Saving. So let's say that we'll go back to water again, and we're on Megan's place here. Now, actually, I'll go before that. Let's say that we're going to build a boundary. So the first thing, and we will want to know where you are, right? So one of the first things that we ask anybody to do is go to the polygon tool. So this one up here. And with this being a boundary, what I want to do is I just want you to type your boundary, right? So we're in geography. Right, I'll click boundary. I want this to be just outlined. I don't want it to be filled, because with polygons, you can either have a fill color or you can just have the outline color, right? Typically, I'll make a boundary red, because red is the color of fencing. And if you want some guide as to, just click on that. If just as an aside, oops, I'll generally make that 3, so it's a thicker line. And if you want just a general guide to what line styles to use, then we've actually developed that in the Agrarian's Handbook. Now, this is all based on another app I use called Map Info, but there's limited polygon. So when you do polygons in Google Earth, you can only have solid colors, and you can change their transparency. That's all you can do as far as that. There's no patterning like there is here for polygons. Similarly, with line styles, there's only one line. There's only one line style, and that's a line, right? There's no ability to have a line which looks like something else. So you just have to play with your colors then. But at least here you can use some of these here as for guidance as to what colors you might use to indicate different lines that you use on a map. All right. So generally, when it comes to fencing, we'll use the red colors. So let's say that your place is this. So you might map it up like that, and let's say it's like that, just for argument's sake. Now, you might tighten that up by zooming in, and if you can see particular fences and stuff like that, you'll shift as long as you've got this active, then you can move these nodes to wherever you want them to be. You might notice that there's a bit of distortion, and that is because, again, Google Earth has got this imagery which it's putting onto a sphere. And so when you draw lines of a particular distance in some areas, depending on the resolution of that imagery, that line will seem to be not straight. Don't get too hung up about that. That's just different projection systems, and you trying to draw a horizontal line on something that's actually spherical. It's weird stuff, but yeah, don't get too hung up about it at this stage, right? So that's what we do there. So when you've done that, we'll click OK. Now, if I want you to share that with me, or anything for that matter out of here, you might want to share the whole template, right? Or the whole geography layer, whatever it is. All you have to remember is just whatever you click on there, you just right click and then save place as. Now, if it's a lot of data, then you save it as a KM. It doesn't really matter to me whether it's a KML or a KMZ, just as long as you save it. So save it where you've got it. And then when you go into, and you go back into the workplace and you're in here and you want to share some data with us, well then you've got a couple of ways. One is that, why is that working so slowly? I'll just reboot that. Goodness me, I'll just get that again. Hang on. Come on, move along. So we'll go to week 4 and say you want to share a bit of data with us, a bit of map data that you've done. Okay, so you'll go, there's a couple of ways you can do this. You can go add file, and you can just choose a file as long as it's no bigger than 100 megabytes, and you just choose file, pick out that, just go to, yeah, and we'll go to clients, and we'll go to, Brockhouse. We'll go to geography. So say I want to share that particular KML file. Well, I'll just click on that, and that will add that file. And all you do then is just tag Darren, right, and do the usual, right? And then that file will get attached to that, and then I'll get it up so that it looks like a download, like Ray's done here. Ray and Sam have done. They've uploaded a file here. I can just simply now download that and read it, right? So what else we've got is, the other way to do it, of course, is to put it into your Google Earth folder. So let's say we're in, again, I'll use James as an example here. You may well, and so James is in here, I'll put in a new folder, which you might call 2 geography. Right. Now in that, you can now upload, and this is so that you keep everything in as a way of backing up. You can take that KMZ and then upload that onto Google Earth, onto Google Documents, Google Drive. I'm in too many Googles at the moment. And then once you've done that, you can then share that by right-clicking, share, add that share link into the workplace. That's the other way that we can do that, right? So there's 2 different ways. All right. Importing data. All right. So importing data is something that a lot of people will be doing. So for this case, I'll just get rid of this. So delete. There's a lot, and I won't be able to cover all of this today because we've still got to do some other stuff. I'm going to be very broad brush. So what I'll anticipate is that we will probably have another session on this over this week or the next week to help people who are still trying to get their head around different things, because there'll be a few of you who have the same problem. And I might say, hey, how about we have a meeting at this time on Thursday morning, and a few of you can come to that, or anybody can come to that meeting, and we'll talk those things through. That's usual, and that's something we've done on most of the Rexes so far, because there's a lot to do in this space and a lot to get your head around sometimes. Anyway, and some of you might have anomalies that have to be dealt with. Well, that's, yeah, welcome to our world, and that's something that will help you work through. Anyway, so let's look at, so say this is James's, and James has had, he's had a flyover done, as he has. So what I'm going to do, I'm going to be in geography. Now, let's say I might go into geography, and I'm going to add another folder, and I'm going to call this aerial photo, right? Because you've got the Google Earth imagery, but then you actually look at it and go, yeah, I want something better. So I've flown my drone. Let's have a look at what that might look like. So I've hovered there, I'm on there. So I'll go open. And what I'll do is I'll go to Rockhouse Estate. And as you can see too, we use this same table structure throughout, which you might have seen already. So we've got in geography. I've got some stuff here. Now, we've done a couple of different images here. So so when we produce using the drone deploy service, when we export images, it produces images at a particular of particular file types. So it creates a TIFF, which is an image file, but it creates that TIFF so it's geographically placed. So it does what's called, it puts it through a process of vectorization, which means you take a raster, which in GIS speak is an image, and then it vectorizes it because it puts it onto a place on the map, right? So that data is all inbuilt in this KML file. So I just have to click on that ortho mosaic, and it'll take me to James's family property. I don't know why I put it down there, but anyway, we'll fix that in a minute. And so there is that Google Earth, that drone footage that we took of that particular part of his property. Now, I'll just click on there because it's popped it down there and just show it. Sometimes this happens, right? So you've got to know how to deal with it. So what I'm going to do is I'm going to cut, and I'm going to go back up to where we were, which was aerial photo, and I'm going to paste. So just paste. And that goes in there now, right? And you might want to change it. You look at that and you might go, wow, what does that actually mean, right? Well, you might just put a date on it or whatever it is. Particularly if you're using drones and you're doing successive work, you might even make a folder, a subfolder, and go, okay, because I'm using the drones, I'll call this one, I think this was October, yeah, so October 2018, right? And so you'll pop that now into that there. I'll get rid of that. So now we've got October. Now let's say you do another one in January of 2019. Well, you'll create a new folder and pop all of those 2019 photos in there and so on. So once you've got that in there, now you can zoom in and you can see that the resolution is substantially different. So if I turn that off, you'll see that that's the native Google Earth resolution, and that's the resolution that we've been able to bring it into through doing a drone flyover of this place, right? So that's how you do that. Now, let's say that you don't have data of that quality and that you're trying to do a few different things. Well, there's another way of playing this game, right? I won't open up a new folder because I'm conscious of time and we've still got a fair bit to get through. Let's say that I'm on this property and I've found a map off the internet of it, and I could only take a screenshot of it. And I want to bring it into Google Earth because it's got some topography on it and this, that, and the other, right? Well, let's see what we can do there. So I'll open. Oh, actually, sorry. Go to image overlay. So that's this one. So you've got place mark, polygon, line, and image overlay. So you go to there. Now with this, you'll go to browse, and I'll just see. see if I've got anything that I prepared at James's, so I don't have to go hunting around. Okay, where are you, James? Just down here. Other maps. Land Victoria. So I went to Land Victoria. It's a shit website, if you excuse my language, but it is. And I was able to go there and get a bit of a sense of what the lay of the land was. So I took a screenshot of that particular map. Now, I'll click on that. So that's an image file, and you can see that's come through, right? Now, you'll see that it puts itself, it's got no, it's not vectorized, it's got no geographic data to this at all, and that's what we're going to turn it into. So we're going to vectorize this by moving it around. So these arrows, or these green bits here, are for shrinking and swelling and for moving, and this diamond one here is for rotating, right? So what we're going to do, now I'm going to try and match this up with the underlying landscape, right? And so what you have to do here is change the transparency so you can still see the data underneath, and try and move it around so it all blends in. And this can be a bit of fun, but because they're using different projections, so I'll just zoom out a bit, get that out of the way. This is where having a bigger computer is useful when you're doing this sort of thing. Anyway, so I'm just going to shrink that up, and I'm going to try and get it so that this actually matches up. And there's fortunately a few features to do there. There's the river, which is lined as roads, freeway, all this stuff. I'm just going to keep shrinking and swelling and moving it around until I'm pretty satisfied that, and you'll zoom in and out until you get in. You'll look at critical parts like little corners or streets, or it's mainly the roads that we use to guide us. Anyway, so you'll do all of that until you're pretty satisfied. Now, let's say that that's all you've able to get as far as contour data. Well, great. Well, what do you do then? Well, this is when you get to the, and I'll stop here because I could spend a bit of time. I'll get that pretty well right. Now, I'll leave that there. Now, I want to get the contour data off this because it's all I've got, but I don't want to have all of this noise of this ugly map there. Well, what I'll do now is I'll go to here to geography, add another folder. I'll call this topo, for example, and I might make a subfolder in that, which I'm going to call VicMap 10. So the source of the data, right? And that goes in there. Now, I go to my line tool, and this is my life sort of early in the digital era, was digitizing contours. So going along and literally copying the contours. Now, I'm not going to do a whole contour, but I'm going to show you, might do that one. Now, if you know what elevation that is, so let's say that is 490, I'll call that the 490 meter contour, right? And I'll do that. And then I'll do the 500, and it'll be another line, right? And you might end up with 20 of these across your place. If that's all you've got, then that's all you've got. Now, I can turn that off, and I've got that line behind over the top of my map, right? So there's different things that I could also do that with the boundary. So once I've got that all pretty right, you might have multiple titles, as this property does. You can see all of these different black lines here. Well, they're marking out the different land titles or land parcels that you have. You might want to create a layer where they're marked on your Google Earth map as well, so that you're building up all of these layers of information, which you can come to one place and see them visibly and share them and so on, right? So you've got all of that geographic information in front of you. So there's that, all right. Let's importing image overlay, GPS data. Let's go to here because I think this will probably be the best one. What do we got here? We use an app, and I know Javan Banakovic mentioned this today as well, or in a post yesterday. We use an app which is called GPS Kit. So I'll just go back to here. So go to your So again, use the workplace in these ways. So you go, oh, I want to know about GPSs. All right, well, try the hashtag first GPS, and let's see where that takes us. Yeah, I'll leave this page, and let's see where that takes us. Right. So, all right. So there's only one. It looks like only one tag of GPS. Well, let's just try GPS. See where that takes us. Right now, there's a lot of so. It takes us straight to this. Now, what we did a while ago, we've got this ongoing thread on smartphone GPS apps because a lot of people now use their smartphones instead of using off-the-shelf GPSs. And this thread from over a year ago has a list of Apple or iOS and Android-based GPS navigator apps, which you can install onto your phones, right, or devices. So one that we use most commonly is this one here called GPS Kit, and it's a really great app, and I'll show you some of the attributes of that. And some of the others, they all have various degrees of capability and use. And this is the one that we in particular use because it integrates in very well with Google Earth. So what we've got here, we can go around a property and mark a number of waypoints, which can then be used to visualize later. So here you can see me in my thongs or flip-flops, and right at that point is some sort of something of interest, right? Now I haven't labeled that, but I may well label that as some in the field because when you look at the app, it's you take a waypoint and it'll allow you to actually name that point, right? So we do that all the time. Here's the group looking at some trees when we're doing it. Here's a crossing which I've labeled, and you can see here. I'll click on that. Oops, and that shows what it doesn't. There's no photo there. Anyway, it marks stuff that's got a photo or it doesn't. There's the spring box that's up the top there and so on. So you can use these apps to actually mark things out. I was talking to somebody yesterday in the field, and you can use these apps to actually mark your grazing areas. And this was something that Tom Bradman did quite a bit of years ago, and I'll just show you some of that. Here's Tom. Now, Tom used Measure Map, I think it was called, was the app. Just used his iPhone. So now Tom had gone and measured. So he'd used his app every time he moved his cattle. And so what he did was he uploaded that data once a month. So this is going back to 2014. And so in that month, it shows that he had grazed 23.75 hectares and that there was that perimeter. Now, within that, though, there were the individual periods, which are these little blocked out areas that he had marked out. So when he did it, so he's got a perimeter fence, of course, but when he put the temporary fence across, he actually marked that out and then recorded how many animals were in there at any given time. So in this area, the animals were in that area from the 15th to the 19th of March, and there were 64 animal units in there. And so when it came time for him to do his grazing planning, he was using Google Earth with his advisors as well, because he could just share all of these grazing records, and we could go through and advise him on how to devise his grazing plan. Because the other thing that you can do in this is, of course, when you're taking those various points, is take photos. You can take photos before and after, and there's a whole range of ways that you can use this. Now, see, Pablo's got his hand up. Is it all good, Pablo? You can hear me now. I'm assuming that's what he was asking. Okay. James, you had a quick question? Okay. You there, James? Okay. All right. Okay. Oh, good, all working. James has asked, will you cover how to collaborate on models? I might need you to elaborate on that if you can by voice, James. So if you can just unmute yourself there or whatever, that would be good.
Yeah, can you hear me?
Yeah, good morning,
Yeah.
mate.
I get how to share models and sort of post them, but if you wanted multiple people working on a model or inputting into a model,
Yeah,
where do you store that model?
Yeah, good question. One of the limitations of Google Earth is that it's not Google Drive. It doesn't function like Google Drive. So imagine you're in Google Drive and you're all working on one document. Well, it's a live document and it gets, like, so imagine we're in this space right now. You had access to it and I had access to it like you do in Google Drive. And I made changes here to these lines. Well, then you'd see those changes immediately as well. Google Earth doesn't work like that, unfortunately. That would make it a super useful collaborative mapping tool, but it doesn't. So the only way that we can deal with that, James, is by versions. So if I, for example, I had this particular folder in front of me now, I might save that place and I'd save it up to Google Drive, which is the collaborative cloud, right? And I might give it a version number, right? And then you might have a side note in the workplace if you're using that as your chat tool and say, I've just updated this and my latest version is version 21. And you might say, actually, no, let's can that. Let's go back to version 19 because that was the one that we liked the most. Right? As long as you've saved that file, as long as you've saved that version, you won't get things lost, right? If that makes sense.
And I suppose you could do the versioning just on the layer that you're
exactly
collaborating on.
Yeah, exactly.
Yeah. Okay.
Yeah, and that's again why it's important to have all of the folder structure set up properly or well, so that you can overcome some of these deficiencies that the app actually has.
Yep.
But I'm just trying to think. I'm not aware. There may well be, but I'm not aware of any collaborative mapping tool out there. There may be one, and that'd be great to hear about. But yeah, it would be a really great thing if I had my magic wand and I was able to talk to Dr. Google. Well, then there'd be certainly things that I'd suggest that they would improve upon, and that'd be one of them, because there are a lot of people use Google Earth as a collaborative mapping tool.
Yep. Cool. Thanks.
And of course, in this space, wouldn't it be fantastic when you've got, maybe 4 or 5 people working on a farm together, and you'd love to be able to have each individual not go through this, a whole range of what's appear to be unnecessary steps. Anyway, it is what it is.
Thank you.
No worries, man. All right, so continuing along, what have I got there? GPS data sharing, I think I've dealt with that already. If anybody else has got any questions before I get onto the Keyline geography stuff, please chime in now. We'll go from there. I'm just going to have a quick sip. Okay. Well, we shall proceed. Now, there's other data that's out there. So I'm just going to shift over to discussing some of the other data, because a lot of you are going to be at this point where you go, yep, it's all great. I can understand how to draw on Google Earth. I can import some pretty crappy data. What about importing really good data? Right, and what data is out there? Now, this is where you're going to have a bit of fun. And there's a variety of different places, and I'd love to, I'm a bit of a mapping cartography junkie, so you've certainly got me in my topic of interest. So this is where I'd love for you to go in and particularly interact on the geography layer, because there's a lot of people who are outside of this, who are outside of our Rex bubble, who are in the workplace, who love to talk about maps too, and who have a tremendous amount of experience. So if you've got broader questions about data and all of that sort of thing, try and have it in here where it's a bit more public, and you might be surprised. Other old Rex participants and other associates and whatnot in the workplace will be really stoked to come in and have a bit of a chat about that. Like you might say, look, I'm in, like the other day, I think it was Andy Promisel and I were having a chat, and I don't know if Andy's on here. I know David's on. I saw him before, David Atwell. We were having a chat about their property in Virginia, and he was talking about buying a drone and doing all this, that, and the other. And I said, I think in Virginia there's really good LiDAR data. Now, he didn't know that, and so we were able to, on his behalf, well, he went fishing for it, and he went, oh, yeah, there is this really good data. He got the LiDAR data, and which is a really high-quality survey instrument for determining topography and so on. And we were able to create a range of topographic maps for him, or take that data, convert it into something useful, and away we went. Now, so if you're in particular places, use Google or your preferred search engine, and you might go, right, Virginia, for example. We're in Virginia, and you might go LiDAR, just something like that. And you go, oh, right, the Commonwealth of Virginia has got a whole set of LiDAR data. So we'll click on that, and then it might take us to a map, and we go start looking at it, and on we go, right? We find out, typically, it doesn't look like this, in this case it works that way, but you will go to a home, and there might be a map, and you'll zoom in, and then you may well be able to download the data that's appropriate to your site. Now, here in Australia, we have a website called Elvis, which is an acronym, of course, and it covers all of Australia. It's from Geoscience Australia, and you can zoom into your place and see, I'll go to New South Wales because it has the best coverage, and you can go to your place. Let's say we'll go to well, let's go to Richmond North. We'll go there, that'll do. And it gives you this sort of crappy background map. This is where Yeoman's Yobani is. And so let's say that my property is this area. Now, it's got enough information there in terms of watershed that you can take that data. So what I'll do now is I'll just draw over an area. So I'll just drag the map there. That's the area of interest. And then from that, it gives you a whole range of different data sets that you can download. So you'll download, so that 1 meter, is that one? I can't see it. Yeah, that's the 1 meter LiDAR data. I'll download that, and then it'll come through to me in a particular form, and you go, oh, gee, I don't know how to deal with that. And then you let us know, and Georgie or myself will be able to get that data converted into a contour map for you. All right, so Ben, thanks. No need to answer in depth, but can you point me to a program and or process that you or Georgie have used to strip out the white, grey, black background from image overlays to just leave the contours? Have tried GIMP, but no success so far. That might be a good thread to put up on in the geography section if you could, Ben, because that's, I don't know about GIMP, and I would probably at that stage defer that to Georgie. So yeah, maybe take a screenshot or whatever, or provide the example and pop that in there, and then let's see where that conversation takes you. All right. Yeah, Ray and Samantha, is the 1 meter digital elevation model, DEM, the best for a topo? It should be for a topo. It's a really great question, because it's always about where the data, how the data has been created. So you've got to understand that, and I go to a bit of depth in that in the geography chapter. So I can't recommend. I mean, we spent 5 months writing that geography chapter. Put a lot of effort into taking some really, really complex techniques and making them so that I can understand them. So I figure that most of you are smarter than I am. So if you can read it, if I can read it, you can read it. So so go through and read that. So that you understand the background to some of these questions. How is data actually created? And can you trust it? Because that's something you're going to do. You're building maps so that you can then go and do plans based on those maps, and then you're going to spend your capital on developing your property based on that information. Well, you want to make sure that that information to start with has actually got some truth to it, because otherwise you can make thousands or hundreds of thousands of dollars worth of mistakes because the map is not the territory. And that is always the case, but sometimes it's really not the territory, and you really need to be clear about that. So great question, Ray and Samantha, because a 1 meter, well, put it in perspective. What this means when you say 1 meter, what that actually means is that when the lidar, when the lidar or whatever is creating the digital elevation model, it's doing it at a particular resolution, or the data has come back at a particular resolution. Now, if it's 1 meter, that means that it's 1 meter per pixel. Now, that's pretty good when it comes to mapping of rural properties to an extent. So it means that you've got a 1 meter square, and that equals a pixel of data. So, and a pixel's a small thing, right? So it's not bad. Now, from that, that means that you've only got a meter square of variation. So generally in 1 square, you're not getting a huge amount of variation in elevation, right? Typically, unless you're on a really steep site, but typically you're not. So that's really useful data from which you would then create a topographic map. Now, let's see if we've got an example there that's been created more recently. Let me think, because I've just switched back computers, but I always use the same hard drive. Oh yes, we did that the other day. Clients. So Ben, this conscious ground place that we did the other day. So Georgie, we went through this process. You'll see here, this is a new client that we're working with up in the Northern Rivers of New South Wales. They needed a contour map, so we went to Elvis. We got the digital elevation model from that, and then from that we got Georgie then created the KMZ file, which should now take me there. And from that, we were able to create this really sweet contour map, which I might use in a minute for other purposes. And these are 1 meter contours. And what Georgie has done is he's made the 5 meter intervals, or he's highlighted the 5. So this is where you look at what's called major and minor contours, and which is typically pretty useful in cartography. And what he's done is he's created majors, which are 5 meter intervals, and the white are the 1 meter contours. Now, so in this case, Ray and Samantha, what we've done is we've used the 1 meter digital elevation model from Elvis, and then we've taken, because it's just a polygon, right? It's got no contours on it, but we take that and we create contours from that digital elevation model. That's how it works, right? So yes, that is the best you'll be able to get generally from the government. When we use drone deploy and we use ground control points, as we've done for, say, with like James, we can get the pixel down to generally a usable pixel size is between 10 to 20 centimeters. So it's a quanta of accuracy greater. And Georgie says to me that if we're doing dams and all of that sort of thing, and we're using data that's derived from particular sources, then it's a minimum of 1 meter, 1 to 5 meter 1 to 5 meter pixel resolution is the minimum for doing dams and a lot of different stuff, and general landscape understanding is what we want. But then when it comes to doing roads, where we're trying, or anything that has gradients involved, then we want to be half a meter, so 0.5 meter per pixel. And that's where, as I've talked to you before, Ray and Samantha, is where you might want to do, and I've also talked, I think, to Ben about this as well, that you might want to do specific higher resolution topographic studies of particular parts of your property, not the whole thing, because the expense of doing it across the board is too much, and you're only going to use that, or you're only going to need that high resolution for particular activities. So don't go and spend and you got a 2,000 acre property, for example, and you're just doing some really high resolution work on 50 acres of that. Well, don't go and survey the 2,000 at high resolution. Just survey the 50, and that's because that's all you actually need it for. So, yeah, I know there's a lot to get your head around here. I'm sorry I can't make it any better than that, but and that's why we've devoted the weeks that we have, and it'll probably be that we'll devote the rest of the year in your subscription to some of this for some of you, because maps are important, and we rely on their accuracy a lot in the application of our capital. Right, so no worries, Ray and Samantha, I appreciate you thanking me. So let's talk about, unless there's any other questions, I think I've got those. No other hands up that I can see. Good. Wheel of the Year. Don't know who that is, but it's an interesting name. Right. Let's look at Keyline geography for the time that we've got left. And I'm just going to go back to here and look at the presentation. Now, some of you who've dipped the toe in Keyline would know that there's a few books that are out there, and they started in 1954, and the last book that was functionally written about Keyline was 1994, apart from the Agrarian's Handbook, which is a new version of a new take on Keyline, and if you like, a new take on Keyline whilst actually being very pure Keyline. We're not creating any new story. No, that's not right. We're not creating any new findings, as it were. Anyway, we'll get through that. Within the Keyline plan, that's the task work. So I've got out of order here. I'm just getting in the right order. That's meant to be down there. Within the Keyline plan, there's a few issues. Within the Keyline literature, I should say, there's a few issues. A lot of people have read this book, and this book is, I've purposely not included this in this list of books here for a reason, or in this list here, because this book, P.A. Yeomans released in 1981, and it was an amalgam of this 1954 book and this 1966-68 book. And so when you open this up, as someone who's read every bloody thing that there is to do with Keyline, more or less, when I open this up, I go, oh, I can see very clearly, because I've read everything, that it's basically all he did was, well, all these publishers did was somewhat lazily got two books and didn't even really edit them that much and just banged them together into a new tome. And in doing so, they resurrected some concepts which are erroneous. And Ken Yeomans made this point in the preface of his edited version of all of his father's previous books, except this one, because he didn't include that because of its errors, was that when they did the edit on this Brown book, they brought back a concept which had not been presented for 30 years. Now, when you read the Keyline plan of 1954, it's a really raw. Like, I think he wrote it too early. I think he not long got into this, not long tested all of the stuff, but had ants in his pants and put together the Australian Keyline plan. And it was a best-selling book. It sold tens of thousands of copies across Australia, and it really put Yeoman's name, it put his name out there. He became quite well known very quickly. And within a very short time, he had literally thousands of people per year coming to his properties out of Sydney to see the marvels of all that he was doing. And he was an entrepreneurial kind of guy and all of that. So, he lapped all of that up. So it was, there's been, I don't know of anybody pretty well in the agricultural scene who's pulled as many people up until Joel Salatin. And even Joel didn't, and he's in the United States with a much greater population, did not pull the crowds regularly that Yeoman's did on his property. It was quite a profound thing. So he did that, and at that time, because he was learning as he went with his development, he had stuff in that book which was wrong, and it wasn't completely tested. So I think, when we look at the books and which are the books that have the best information, I go to this one, The Challenge of Landscape. This is where, in that very short period of very intense scrutiny and testing and so on, that Yeoman's really nailed some of the things that really matter today in our application of Keyline. So he really nailed the geography and the patterning and a few other elements of it. So when you read this book, this concept was in this book. Now, this is the concept that's known as the common Keyline. So that was featured in that book, and it was never mentioned again until this book came out. Now, this book came out, and it came out around the same time as Bill Mollison and David Holmgren and other permaculturalists were coming along. And when you find out about something, what do? You go and buy the book. Well, of course, you buy the latest book, because the latest book is the one that's got the latest information, right? Well, not in this case. It didn't. It regurgitated 40-year-old information into a new piece, and some of that it regurgitated was just wrong. And this is and so when I look at the Keyline interpretations, if you like, the Keyline geographic interpretations of some people, like the confusion around where the key point is, the confusion around, or some people's definition of where the Keyline is, and so on, when I look at that, I go, oh, you've got it completely wrong. Case in point, here's an email I got the other day from a good friend of mine. Where are we? Let's have a look here. Brad Lancaster. Now, some of you would know Brad. Brad's done amazing work with his rainwater harvesting for drylands. Now, Brad's doing a new version of his book, and he reached out to me and a couple of others to ask about can I review some of the stuff around his Keyline concept, right? So how to build a diversion swale. Now, Yeoman's didn't build swales, and apart from which, anyway, he's created a particular definition of the Keyline and the key point and blah blah blah. And he asked, Brad's a decent bloke, so he reached out and said, "This is what I've got. That's the break point. That's the key point. That's the Keyline." Da 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 da. And I'm going, "Nah, that's not right, Brad." But thanks for asking. Good on you. So I went through. While I was waiting, I said, well, there's the key point, just as a starting point, because the Buddha has all answers. And from that, because I was out and about, then I shared with him our section on Keyline and looking at in the Agrarian's Handbook and all of the definitions that there are of landscape geographic definitions in Keyline, and how we've kind of tried to help people understand the geography of Keyline. That actually, this is where the key point is, not at the break of slope. It's actually at the point of, in a primary valley where the landscape starts to flatten out, that these are the patterns of Keyline and so on, and referred to all of this information, the offending diagram, as I call it. And so Brad's gone through all of that, and da-da-da-da-da, and we've gone through the reviews, and now he's come back and now his book looks like this. So he's decided, I'm just going to include your diagrams with your permission in my new book as a result, because I can see that that's where the truth lies. Which, when you one of the quotes that I gave about this is from where are we? I don't know if I've got it in there, but E.F. Schumacher, when he wrote his book, anyway, E.F. Schumacher, when he was looking at all of this years ago, he said that there is a perfect truth in Keyline, and that's what he saw. And that's the issue that we've got here, is that how do I understand what that truth is and how do I apply it? Well, there's enough of that. I've talked enough about that now. So let's have a look at this map. Now, there's been a lot of confusion about a range of different things. The most important things I want you to do is to start with, just go to geography. And what I want you to do there is add a layer, which I want you to call Keyline Geography. All right. And from that, inside, I probably should have set this up so it included that. Maybe a later version does. Now, I've got Keyline Geography. What I want you to do is add a couple of other folders. One is called Main Ridges. And another one is called Main Ridges, add folder, Primary Ridges. And the third one, excuse me, is Primary Valleys. Right. So once we've done that, so that's there in there. Now let's just go back to the Agrarian's Handbook for a moment and go down to the chapter sections here. So section 2.10, there's a description there of all of the what I will call the official, that is out of Yeoman's own mouth, descriptions of that make up Keyline geography, or the geography of Keyline. Now, what we've done in here is we've tried to help you understand through our maps here of a real landscape, by the way, of this zone of Australia, where we're starting from the right up at the main ridge, and which is the horizon of the landscape, and bringing you right down to the ocean. So we tried to combine a discussion around stream orders with Keyline geography, some of which hasn't been done very well, or hasn't at all been done at all. So anyway, so what you can see here now, this is where I might get you to look at the so-called handscape, and you'll look at your hand, which is in itself a landscape, and you might look at where is the main ridge. Well, the main ridge is your knuckles. All right? It's what's also called a divide line. So here in Australia, we have the great dividing range. Well, it's a divide between the inland of Australia and the coastal regions of Australia. It goes all the way up from South Australia all the way up to New Guinea, into the Owen Stanley ranges. So now that, or there's the Andes, or the Cordillera in South America, or there's the Rockies in the United States. So there's all sorts of different places, and Canada and so on. Anyway, when you're in a foothills landscape, say this is your farm, just this section here, your farm is made up of potentially of a horizon, which might be right at the top of the catchment, and that's called the main ridge. And then in between that are a range of these fingers of ridges, which are convex in shape. And then in between them are a range of valleys, which are concave in shape. All right. And so primarily what we're trying to do, and what we'll look for you to do over the coming weeks, is try to map those as a starting point, because they are effectively the skeleton, the geographic skeleton of your landscape. So, you know, you look at the skeleton of yourself, and it's largely a convex landform that your body hangs off, as it were. And there's apexes of those convex lines everywhere. Now, why is all of that important? Well, because a lot of our work in farm planning is, well, if you put to one side our own human context and economic context and whatnot, just park that to one side. A lot of our work is actually in trying to adapt a landscape, adapt the management and development of a landscape to fit within the shape of that landscape and the climatic conditions that you find yourself in. And so when we look at how a landscape is formed, it's formed by a few factors. One is tectonic factors, which are very much outside of our control. You know, the moving of the plates of the world. So there's that. And then there's then it's a relationship between how water and wind, and to an extent sunlight, but particularly water and wind, interacts with the geology of your landscape. And so different geologies throw up a different land shape. And so in Yeoman's scale of permanence, so you had climate number one. The number two part of his was not geography, it was land shape, right? So your land shape is determined by tectonic factors, the kind of geology it's actually made of, and the interaction of those factors with the weather patterns that have impacted that over time. And that will throw up a whole array of a myriad of different shapes. But in between all of that, there are underlying shapes that always exist. That is, there are always main ridges, there are always primary ridges, and there are always primary valleys. It doesn't matter where you are. Those shapes always exist, right? And so, which is good, because it's helpful for us when we're trying to negotiate stuff that is quite complex, that underlying this. So I think the genius of Bill Mollison it comes through in this, in that he was able to break down that there are universal patterns which can be applied to anywhere and anything. And so from my perspective, the genius of the geography of Keyline is that you've got some very simple things to identify in what otherwise appears to be a very complex landscape. So that's why we work with people like you to say, all right, well, we want you to identify the ridges of your landscape and the valleys of your landscape as a starting point. Because if we're going to make the most of our landscape in a whole array of ways, then us working with the landscape that we've got and taking advantage as much as we can of its shape, us doing that is going to mean that we're going to have a much easier job in developing and managing the place, and our control of the water cycle, quite broadly, is going to be much more within our grasp, as opposed to where we fight against the land shape and try and make it do things that it doesn't want to do or won't do. Then we're going to waste a lot of capital and so on. So we've sort of come down to this point where we want you to do, and you might start with your hand. You might go, all right, well, maybe I'll start to draw some lines on my own hand, as I'm often found doing. So I'll go, okay, well, where's the apex of this ridge? Well, you'll go along here, and there it is right there. It's right along the apex of the curve, right? So that's the main ridge, or the ridge of my ridge line of my knuckles there. And then you might go, well, where is it down my fingers? Well, you go right in the center line of the finger, where it shifts right on the apex, where it goes from convex to where right on the curve of your finger, and you go down. And you go, oh, there's the next one, and the next one, and the next one. All right, well, let's do that. Let's transfer that to a map. So I read through this, so I'll let you do that in your time. And you can see here that, you know, we've marked on the map, the dark line, the thick dark lines here are the main ridges. If this is all getting confusing for you, don't worry, just do ridges and valleys, because then it'll become more obvious to you. Because it's perhaps for some of you who have difficulty understanding maps, which is one of the reasons why we did 3D maps here, because it made it a bit easier to see. When you've just got plan view maps with contours on it, a lot of people, it's a whole new language that you don't understand. So we're using different graphical tools so you can go, oh, right, I can see how that works. I mean, I had this bloke in the US years ago who I just couldn't get through to him, and was about Keyline. So I just looked around as I do, and I went, actually, no, not in there. Yeah, here. I was looking at this last night. Keyline geometry. This guy just had no idea. I tried all of these topo maps, 3D maps, sand pits, blah, blah, blah. It ended up with a cucumber. I found a cucumber on his bench, and I did a contour map of the cucumber, and then I explained the keyline patterning on the cucumber. And he went, oh, right. And I even sliced it, which I didn't take photos of. So that enabled, so some way, shape or form, you're going to have to get there if you're going to be successful at, as successful as you can be and realize your potential. You'll have to understand maps at some stage. Or if you can't, if it's just too much, then find someone who can, right? And have them help you, guide you. Now, when I look at this map, I'll just focus on this one, and I go, all right, well, where are the ridges and where are the valleys? Right. Well, let's start. I won't get into main ridges and main valleys because we've only got a few minutes left. But let's just look at ridges. And I'll go, okay, well, I need to mark out, and this is one of the exercises that we have for you. I want to mark out the ridges of this property. So what I'll do is I'll go up to the top of the landscape and I'll go, okay, well, that's clearly the top because you can see the contours are all rising. What you can do once you've got a map with contours on it, you can say, oh, that's the 182 contour. I'll click on this one down here. And this one's the 25 contour. So we're getting pretty low. We mustn't be too far from the coast here. This is the 9. Oh, yeah, right. Sea level rise might be an issue here. Anyway, so we'll do that. Now therefore I can see that this map is actually, or these contours are rising. And as often happens, you'll often have a road which is right on that main ridge because they're nice and flat to drive on generally, and easy to build roads because they're already shaped. So the water falls off them. Anyway, and it's called the scenic drive. Well, I wonder why it's scenic, because you can drive along here and you can see this way and you can see that way. So I'm going to draw a couple of ridges. So what I want you to do, and you'll have a play with this yourselves, of course, if you've not done this before, the first time you'll do it will be the worst time you do it, but that's just the way it is, with no worries at all. So what I'm going to do is I'm going to grab my line tool, and I'm going to call this PR1, right? So primary ridge 1, or you can just call it R1 if you want, if you don't want to delineate the difference between ridges and valleys. Primary ridges and main ridges. So what I'm going to do now is I'm going to draw out this ridge. So I'm going to select that. I'll select a line style and color that'll work. So I'm going to go with this one. I'm just going to go with a nice yellow and make that 2 point. Yep, that's good. And then what I'll do is I'll just pick the apex. So you're just going along here and trying to find the apex of this ridge close as you can. Don't get too hung up about it. And so you go. And we'll go all the way down until the ridge, oops, this is where you'll use, because I've just used that tool. And I'll go all the way down until the ridge, as ridges do, run into another landform. In this case, what we've got is a creek running through here. So that's the end of the ridge. So you might look at this, and from your handscape is you've got these ridges coming down, and then on the other side of the valley, you've got another set of ridges coming down, and they come down and they intercept. And the bit at the bottom is a creek or a river or whatever, or it might be a valley. It might go out wider and it's got a big floodplain between. But that's those ridges which create the meandering ultimately, because they're hard and they're often the steepest part of the ridge is right at the end, just as it is with your fingers. You look at the landscape of your fingers, as it goes down, it's quite gentle, and then it gets to the end of your finger and then it precipitously drops off. And if you look at that in a landscape, that's exactly what happens too in a lot of cases. You'll get this precipitous drop off right there, because the edge where the water's run along, it's washed off, and all you've got is some stone or rock exposed, which is the underlying skeleton of the ridge, which is part of why it's there, is because it's shallow soil and it's resistant to erosion. So there's a geomorphological reason as to why it's a ridge, not a valley in the first place. It's got a different resistance to erosion. So there's R1, right? Well, that's one ridge. Now let's have a look at the next one. Well, there's plenty of others in there. Let's have it. So I would, in this context, call that a main ridge, because it's got lots of smaller ridges which are coming off it, which are called primary ridges. And this is where I'll invite you to start reading the handbook to get that delineation a bit more clearly. So what we'll do there is we'll go R2. I might put PR because I know it is a PR. So this is primary ridge 1. And it's going to be the same line style perhaps, or if I'm changing the order of ridge, I might make that a 1-point line. And I'm going to go here, and I'm going to go, oh, right, that goes out through here. So bang, and then through here, and here. And it goes all the way along until it hits there, and then it hits another divide line, which being a creek. And then let's do this one. There's another one which comes off here. So there's another one, PR2, and this one goes along here, and so on. Okay. And then there's another one which goes, looks like there's a valley that runs down through the guts here. You can see just zoom in a bit, come in a bit. And then we go here. All right, so there's another one. And I'll just do one more before I illustrate a point. The main point of doing this, which will become obvious to you as you get further into this planning program, which I'm so grateful for PA Yeomans for coming up with this whole methodology, because it makes my job right now, as you will get to understand, so much easier in terms of developing farm plans. So let's say that that there was nothing developed on this landscape, because that sometimes does happen, and you're looking at deciding, largely where to put things. Where do I put that road? Where do I put that dam? Where do I put my house site? Where do I put trees? Blah, 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 blah. All these questions. What we found with the analysis of a landscape using the Keyline geography is that once you define these patterns across your landscape, once you do that, then it becomes relatively easy for you to make decisions. So, for example, if I had no road on this property, where now would be the best place to put that road? Well, of course, it'd be right along this ridge, because you look at it, you look at the spacing between all of the contours here. Whenever the contours are wider apart, that suggests it's flatter. When they're close together, it's steep. And it's general that in ridges have flatter topography than valleys. So if you look at all the steeper parts of this landscape, it's all the valleys that have the steepness, not the ridges. So if I was going to build a road along here, want to build a road here, which was resistant to erosion and had good sight, good access potential and all of that, It's going to go right bang on top of this ridge. What about if I want to get from here down to this creek flat down here? Where am I going to go? Down the valley? No way. It's wet. It's hard to build. It's just going to get wetter. It's going to have drainage issues. You just go straight down the ridge. Now, furthermore, what's that right there? Well, that's in Keyline what we call a primary land unit. Now, the primary land unit, to give you my handscape back again, the primary land unit is you go right up to the top of your catchment and you've got two ridges. That's what's called, so the area in between the main ridge and two primary ridges down to whatever drainage system there is below is what's called a primary land unit. So what we might also call that is the first catchment. Now, why is that important? Well, because if you do let's say that I want to build a storage, a dam just down here. Well, what I want to know is what the catchment is. So what do? When I'm designing the catchment or looking at the catchment, I'll go and do a polygon over the area of the primary land unit because these are the first catchments in a landscape. And from that in Google Earth, I can go, oh, right, it's X amount of square meters or X amount of hectares or acres or whatever unit you want to use. And you go, oh, okay. Then now from that, I can calculate how much surface area there is. Therefore, I can use catchment formulas to then determine how much water runs through that in any given year or in any given moment when we're trying to design for what's called peak flow events, which we'll talk about when we get to the water layer. So it's fundamentally part of a whole range of other decisions that you'll make or other questions that you'll be asking as you get down the layers, that you start with something quite primary. And I think that that's, you know, such a gift that Yeomans gave to us to have this very simple diagnostic tool of breaking, a universal tool of breaking up the landscape using this particular geographic analysis, that once we do that, then a lot of the questions that we're going to be asking down the track are going to be answered by us going back up to this simple diagnosis. If that's not clear to you now, over time it will be, and for a lot of you, I expect that we'll have some supplementary sessions. Again, this is one of the big reasons why I value having the subscription model, because for some of you, it's going to take a bit of time, and that's okay. At least now we have a financial apparatus through the subscription to support that, whereas before we didn't. So I'm really pleased with that. Okay, well, we better stop there. I could look at primary valleys and whatnot. So primary valleys are the valleys. So you can just mark the valleys in between. I'll just look at that briefly. So you'll go into your primary valley, and with these, you will mark these in the blue, and you'll say, all right, well, the valley really starts about here. It looks, because that's where the water starts flowing, and I might mark that in, right, as being there, and that goes down to the creek. So you might just very simply go across your property and just do the best you can with what you've got and your understandings, and try and map your property out in that way. Now let's look at the task work. Okay, go back to here and go back to here. Right, so task work for this week, because you've all done your holistic context and they're all wonderful. I appreciate reading those that have been submitted. You've got more, of course, they'll continue to flow in. And as I've made the point before, I'll make it again. If all you do in this program, this particular X, is get your holistic context and get your mapping together, if that's all you do, well, fine, that's okay. You do what you can. And then if the next one you come back, you've got your refreshment through the year in between the Rexes where you've asked a lot of questions and learnt a lot more and gone back and looked at things and got all your ducks lined up, as it were. Now you're ready to go in and dig a bit deeper. Well, that's fine. That's exactly fine too, right? So want you to set up your preferences and your folders. That's the first part. Secondly is create a folder called boundary and create that boundary layer. Okay, so create that boundary file. And if you're finding difficulty getting your topographic data, well then of course talk with us about that. Probably if you're looking at that, yeah, use either the geography section in the main what I'll call public forum there, or use this week's folder, the week R13 week 4 farm map and Keyline plan group. So ditto with if you could get any contour data, try and get that together. That will again be a challenge for some of you, but we'll work to help you with that. Also, so that's all we want you to do from the Google Earth stuff. So that should be pretty straightforward to you. Now, as far as the Keyline stuff is concerned, in the Google Earth again, we want you to, in the folder, in the geography folder, like I just showed you, create a Keyline geography folder, and then a main ridge, primary ridge, and primary valley. If you don't want to do the ridge stuff, just delineation, just have ridge and valley folders, and that's it. And then start to develop those lines if you're confident now and ready to go. And you've got, because you've got to have your contour data ready and da 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 da. So just do the best you can with what you've got. And then in the Google Drive, save your geography folder. So go to your geography folder on Google Earth, and I want you to just save that place as. So and that'll grab everything that's in the geography folder. Right, save that as, and then onto your hard drive, and then go to your Google Drive and upload that into a Google folder. A geography folder that you've created, as I showed before with James. Is create a geography folder in here, and then put inside of that geography folder from your Google Earth, and then that will be, then you can share that completely with us, or you can in there, or you can take it apart. You might just get the Keyline geography folder out of that and share that with us, whatever works for you. All right. Most important thing is have a crack, as always. And ask questions, and we'll do our best to help you. And like I said, if we need to, which is likely, we'll have additional sessions. We may even have one-on-one with you through the workplace chat, etc., to get you so you're up to speed. That's what we're here to help you with. All right. All right. Well, I don't have any time for questions, even though I have this panel. I don't even know why I bother having that with this particular session, because it's always over time, so I can't do much about that. There's a lot of detail to get through in a short amount of time. But I want to thank you for joining us today, and hopefully that's helped you. There are some other versions of this particular presentation I've done. I think one of the first ones I've done, or maybe even on the 10-week, the R10 Rex, have a look in there. It might deal a bit more closely with the mapping stuff, but yeah, by all means go and have a look through there or scan through it. But yeah, get back to us and let us know how you're going. All right, with that, I'm going to leave it with you, and have a very, very good morning. Appreciate you all joining us. Hang on, there's one chat. Thanks, that feels very exciting. Well, I'm glad you think so, Rachel, and let the proof's in the pudding to see how excited you are once you get into it. So, but no, it's good, and look forward to your work flooding in and your questions. Thank you, and have a very, very nice day.